December 24th, 1944. The French Alps stretched beneath a canopy of storm clouds, their peaks cutting through the darkness like cathedral spires of stone and ice. At 8,000 feet above sea level, the air was thin, bitter, and unforgiving. Inside the vibrating aluminum fuselage of a Douglas C-47 Skytrain, the twin Pratt and Whitney R1830 engines roared with mechanical precision, their synchronized rhythm echoing through the cargo compartment, where 67 containers waited in silence. Lieutenant Charles Donovan pressed his face against the frosted porthole, watching the altimeter needle oscillate between 900 and 1,000 feet above ground level. The mathematics of survival played out in his mind with cold clarity. Below lay nothing but shadow and granite, valleys carved by millennia of ice and wind, now serving as corridors for one of the most audacious supply operations of the European theatre. The radio crackled through his headset, static, mixing with the voice of Captain James Mitchell from the cockpit. Eureka beacon active. Proceed to drop Zone Delta. The words carried weight beyond their technical meaning. Each syllable represented months of planning, weeks of training, and the collective hope of resistance fighters scattered across the Vercors Plateau. It was Christmas Eve, 1944. Peace on Earth remained a distant prayer, but for the men aboard this aircraft, salvation would be measured in containers, parachutes, and the precision of electromagnetic signals cutting through alpine darkness. The weather reports from RAF Meteorological Command had been unforgiving in their assessment. Air resupply operations in alpine conditions under current atmospheric parameters constitute operational suicide, the briefing document stated with bureaucratic finality. Wind speeds exceeding 40 knots, visibility reduced to less than 300 meters, and cloud ceilings dropping below operational minimums for instrument flight. The German High Command, studying the same meteorological data from their weather stations scattered across occupied France, reached an identical conclusion. Oberst Klaus Zimmermann, commanding the 157th Alpine Security Regiment, had dismissed intelligence reports suggesting Allied air operations during the Christmas period. No competent air force, he told his staff officers during their December 23rd briefing, would risk valuable aircraft and experienced crews on night supply runs through mountain terrain in winter storm conditions. The Americans are bold, but they are not suicidal. His assessment aligned perfectly with Luftwaffe tactical doctrine, which prohibited night operations below 1,000 meters altitude in mountainous terrain unless supported by ground-based navigation aids. They were about to discover the fatal flaw in their logic. Operation Christmas Box emerged from the classified files of the Office of Strategic Services as an experimental fusion of aviation logistics and clandestine warfare. The concept represented an evolution in military thinking, where traditional boundaries between air transport, intelligence operations, and resistance support dissolved into a single, coordinated strike against German supply lines. The operation's genesis traced back to October 1944, when OSS planners recognized that conventional daylight supply drops to French resistance groups had become increasingly costly due to improved German anti-aircraft coverage. The solution lay in technology that bore an almost mundane name but revolutionary capability. The Rebecca Eureka navigation system, developed by British engineers at the Telecommunications Research Establishment, consisted of airborne interrogator equipment, designated Rebecca, and ground-based transponder beacons called Eureka. The system operated on frequencies between 214 and 234 MHz, allowing aircraft to home in on beacon signals from distances exceeding 50 miles under ideal conditions. Each C-47 participating in Operation Christmas Box carried Rebecca equipment mounted behind the pilot's position, connected to a cathode ray tube display that showed bearing and distance to active Eureka beacons. The ground units, weighing 38 pounds and powered by portable batteries, could be operated by resistance fighters with minimal training. Signal range varied with altitude and atmospheric conditions, but tests conducted over English countryside had demonstrated reliable performance at distances up to 40 miles. Drop Zone Delta occupied a snow-covered plateau approximately 12 miles northeast of Saint-Martin-en-Vercors, at an elevation of 3,800 feet above sea level. The location had been selected through painstaking analysis of topographical surveys, resistance group locations, and German patrol patterns. Intelligence reports indicated minimal enemy presence within a 5-mile radius, though SS mountain troops were known to conduct irregular sweeps through the broader Vercors region. The cargo manifest for Operation Christmas Box read like a catalogue of modern warfare's complexity. 67 containers, each weighing between 100 and 150 pounds, carried supplies categorized by immediate tactical necessity. Communications equipment included SCR-300 radio sets with sufficient battery power for 2 weeks of continuous operation. Medical supplies featured recently developed penicillin dose, surgical instruments, and morphine syrets for field hospitals treating wounded resistance fighters and escaped Allied. Weapons shipments consisted of British Sten submachine guns, ammunition, and plastic explosives with timing devices calibrated for sabotage operations against German transportation infrastructure. Perhaps most intriguingly, several containers held carefully tailored Wehrmacht uniforms and identification documents, intended to support infiltration missions behind German lines. The total value of the cargo exceeded $200,000 in 1944 currency, representing months of industrial production and strategic planning. The first aircraft to approach Drop Zone Delta nearly ended Operation Christmas Box before it truly began. C-47, serial number 4292847, call sign Redtail 6, lost its Eureka beacon signal at precisely 0147 hours while navigating through a narrow valley between cloud-shrouded. Staff Sergeant Robert Chen, operating the Rebecca equipment from his position behind the co-pilot, reported complete signal loss, followed by what appeared to be intentional jamming. Signal strength dropping to 0, Chen reported through the intercom system. Getting interference on all frequencies. Possible enemy electronic countermeasures. The implications struck the crew with immediate clarity. German forces had developed increasingly sophisticated radio detection and jamming capabilities throughout 1944, particularly in regions with high resistance activity. If the Eureka beacon had been compromised, the entire operation faced catastrophic failure. Captain Mitchell maintained course while struggling with deteriorating flight conditions. Ice began forming on the aircraft's leading edges, disrupting airflow and reducing lift capacity. The C-47's de-icing equipment, never designed for extended operations in severe winter weather, proved inadequate against the combination of supercooled water droplets and sub-zero temperatures at altitude. Weight calculations showed the aircraft approaching dangerous loading limits as ice accumulated on wings, propellers, and control surface. 2 containers released prematurely when turbulence jarred the cargo bay door mechanism, sending critical medical supplies tumbling into the darkness below. Search teams would later find the wreckage scattered across granite outcropping, the carefully packed penicillin doses reduced to frozen fragments among twisted metal and torn parachute fabric. The loss represented not merely tactical failure, but human tragedy, as wounded resistance fighters would suffer and die for lack of medicines that now lay shattered on alpine stone. Yet the formation maintained course. 5 additional C-47 aircraft followed Redtail 6 through valleys that seemed designed by nature to destroy human ambition. Pilots flew on instruments alone, trusting their lives to gyroscopic compasses and radio altimeters, while mountains loomed invisible on either side. Ice pellets hammered against windscreens with the sound of machine gun fire, and carburetor intake temperatures dropped toward levels that would freeze fuel lines solid. At 0213 hours, salvation arrived through electromagnetic waves traveling at the speed of light. New signal acquired, Chen announced, his voice carrying barely controlled. Eureka Delta 2, bearing 047 degrees, distance approximately 8 miles. Signal strength excellent. The backup beacon, established by French resistance fighters using components salvaged from German radio equipment and British supplies from earlier drops, had activated precisely on schedule. The technological achievement represented months of preparation by resistance engineers working under conditions that would have challenged professional research laboratories. Using vacuum tubes scavenged from destroyed Wehrmacht radio sets, copper wire stripped from telephone installation, and power supplies improvised from automobile batteries, they had constructed a functioning transponder beacon that met military specifications despite its improvised origin. Lieutenant Donovan studied his mission charts while the aircraft banked toward the new bearing. Drop Zone Delta 2 occupied a slightly larger clearing than the original target, with better approaches from multiple directions, but increased exposure to potential German observation posts. The decision to proceed required balancing immediate tactical success against long-term operational security, a calculation that defined resistance warfare throughout occupied Europe. The mathematical precision of the final approach reflected years of training and technological development compressed into minutes of life-or-death execution. Captain Mitchell descended to 800 feet above ground level, flying formation with 5 other C-47 aircraft spaced at 2-minute intervals. The cargo bay doors opened with mechanical precision, exposing the containers to 40-knot crosswinds that tested every engineering specification built into the aircraft's design. One by one, the containers tumbled into alpine darkness, their static lines pulling parachutes open with sharp cracks that echoed off valley walls. Each drop had been calculated for wind drift, altitude, and ground conditions, yet success ultimately depended on the skill of resistance fighters who had spent weeks preparing landing zones and recovery operations. Magnesium flares erupted on the ground below, confirming successful recovery of containers and providing navigation references for subsequent aircraft. The precision achieved during those critical minutes bordered on the miraculous by any reasonable standard of wartime logistics. Post-mission analysis would reveal that 59 of 67 containers landed within 150 meters of their intended targets, an accuracy rate that exceeded peacetime training exercises conducted under ideal conditions. The remaining containers fell outside the primary recovery zone, but were retrieved by resistance teams within 48 hours. 7 C-47 aircraft completed the supply run between 0200 and 0400 hours on Christmas morning, 1944. Not a single aircraft suffered combat damage, mechanical failure, or crew casualty. The weather conditions that German commanders had deemed prohibitive for Allied operations proved manageable for American aircrew trained in instrument flying and equipped with navigation technology that turned electromagnetic spectrum into tactical advantage. Radio communications intercepted by German monitoring stations revealed the confusion and concerns spreading through Wehrmacht command structures as reports filtered in of successful Allied air operations during conditions previously considered impossible. Oberst Zimmermann issued orders for increased patrol activity throughout the Vercors region, but his mountain troops found only empty landing zones swept clean by efficient resistance recovery teams. The strategic implications extended far beyond the immediate tactical success of Operation Christmas Box. OSS planners recognized that the boundary between traditional espionage and aviation logistics had been fundamentally redefined. Where previous supply operations relied on daylight flying and visual navigation, the Rebecca Eureka system enabled precision delivery under conditions that rendered conventional methods useless. German intelligence services, which had invested heavily in developing electronic warfare capabilities throughout 1944, now confronted an adversary that used the electromagnetic spectrum as a weapon of logistics and coordination. Their radio monitoring stations could detect and analyze Allied transmissions, but they could not prevent resistance fighters from receiving vital supplies that sustained operations against German transportation and communication infrastructure. Lieutenant Donovan's personal log, declassified decades after the war, captured the broader significance of that Christmas Eve operation with characteristic understatement. Success achieved through application of proven navigation technology under extreme conditions, he wrote. Results demonstrate feasibility of precision supply operations independent of weather or visibility constraints. Recommend expanded implementation for future resistance support missions. Those dry technical phrases masked a revolution in military thinking that would influence warfare for generations. The integration of electronics, aviation, and clandestine operations pioneered during Operation Christmas Box established principles that would guide special operations throughout the Cold War and beyond. Precision, coordination, and technological superiority had proven more valuable than numerical strength or conventional tactics. The immediate impact on resistance operations throughout the Vercors region became apparent within days of the supply drop. Radio communications previously limited by battery shortages expanded dramatically as new equipment reached scattered resistance. Medical treatment for wounded fighters improved significantly with the arrival of penicillin and surgicals that had been unavailable for months. Sabotage operations against German transportation infrastructure intensified as explosives and timing devices reached experienced resistance engineers. Railway bridges, telephone lines, and road junctions suffered coordinated attacks that disrupted German logistics throughout southeastern France. The psychological impact on German forces may have been equally significant, as they realized that Allied support for resistance activities would continue regardless of weather conditions or seasonal factors. German countermeasures evolved rapidly in response to successful Allied supply operations. Electronic warfare units received upgraded jamming equipment designed to disrupt Rebecca Eureka navigation system. Security patrols in mountainous regions increased patrols during periods of poor visibility when Allied supply flights were most likely to occur. intelligence networks focused resources on identifying and eliminating resistance groups equipped with Eureka beacon technology. Yet these defensive measures proved largely ineffective against operations that combined technological sophistication with tactical flexibility. Resistance groups learned to operate multiple beacon sites, switching locations and frequencies to avoid German jamming efforts. Backup communication systems ensured that supply operations could continue even when primary navigation aids were compromised. The broader technological lessons of Operation Christmas Box influenced Allied supply operations throughout the final months of the European War. Similar techniques supported resistance groups in Norway, Denmark, and the Netherlands, where geography and weather conditions had previously limited Allied logistical support. The success rate of night supply operations improved dramatically as aircrew gained experience with Eureka navigation, and resistance groups refined their container recovery procedure. Post-war analysis by military historians would identify Operation Christmas Box as a pivotal moment in the evolution of special operations. The integration of advanced technology with traditional resistance warfare techniques established models that influenced American military doctrine for decades. The emphasis on precision, coordination, and technological advantage over numerical superiority became hallmarks of successful special operations throughout the Cold War era. The human cost of such operations remained largely hidden in classified files for generations after the war ended. While Operation Christmas Box achieved tactical success without Allied casualty, the broader resistance network supported by those supply drops suffered continuous losses to German security. French fighters who risked their lives to operate beacon equipment and recover supply containers often paid with imprisonment, torture, or death when German intelligence succeeded in penetrating their networks. Lieutenant Colonel Heinrich Müller, commanding German security operations in the region, understood the strategic implications of successful Allied supply runs, even as his forces proved unable to prevent them. His post-war interrogation transcripts revealed grudging respect for the tactical innovation demonstrated by Allied forces. "They turned our own weather against us," he observed. "Conditions we considered protective became their operational advantage." The technological achievement represented by reliable air navigation under extreme conditions reflected broader American industrial and engineering capabilities that German planners had consistently underestimated. The Eureka system emerged from research laboratories and testing facilities that represented massive investments in education, industrial capacity, and technological development, spanning decades before the war began. Manufacturing the electronic components required for widespread deployment of navigation equipment demanded industrial capabilities that few nations possessed in 1944. Vacuum tubes, precision wound coils, calibrated crystals, and battery systems all required specialized production facilities operated by skilled technicians, working to specifications measured in fractions of millimeters and microseconds. The logistical achievement of delivering 67 supply containers to precise locations in mountainous terrain during winter weather conditions demonstrated coordination between multiple military organizations operating across thousands of miles. Intelligence services identified targets and requirements. Industrial facilities produced specialized equipment. Air transport units provided aircraft and crews, and resistance networks provided ground support and security. Each phase of the operation required timing, synchronized to within hours across geographic distances spanning continents. Weather forecasting, flight planning, crew scheduling, cargo loading, and ground coordination all demanded communication systems that could relay precise information rapidly and securely. The successful execution of Operation Christmas Box represented a masterpiece of organizational coordination as much as technological achievement. The psychological impact on German forces extended beyond immediate tactical concerns to fundamental questions about the duration and ultimate outcome of the war. If Allied forces could conduct precision supply operations under conditions previously considered impossible, what other technological capabilities might they possess? The realization that American industrial and technological superiority extended to every aspect of military operations contributed to declining morale among German commanders who understood the mathematical impossibility of victory against such comprehensive capabilities. Swiss intelligence services, maintaining careful neutrality while monitoring military activities along their borders, documented the evolution of Allied air operations with professional interest. Their reports, declassified decades later, provide objective assessments of technological and tactical developments that influence post-war European military planning. The Swiss analysis concluded that Operation Christmas Box represented a fundamental shift in the relationship between technology and tactics that would influence military operations for the remainder of the century. The weather conditions that nearly prevented Operation Christmas Box from succeeding ultimately contributed to its strategic significance. By demonstrating successful operations under extreme conditions, Allied forces established operational capabilities that German planners could not predict or counter effectively. The psychological advantage of technological superiority proved as valuable as the immediate tactical benefits of successful supply delivery. Captain Mitchell's flight logs, preserved in National Archives collections, provide detailed technical data about aircraft performance under conditions that tested every engineering specification built into the C-47 design: ice accumulation rates, engine performance degradation, fuel consumption variations, and control surface effectiveness, all received careful documentation that contributed to improved aircraft design and operational procedures for subsequent missions. The human element underlying technological achievement remained constant throughout the operation. Individual skill, training, courage, and judgment determined success or failure at every critical decision point. Electronic navigation systems provided information, but human pilots interpreted that data and made life or death decisions based on experience, training, and intuition that no technological system could replicate. Staff Sergeant Chen's operation of Eureka navigation equipment required mastery of complex technical procedures under conditions of extreme stress and limited visibility. His ability to acquire and maintain beacon signal while the aircraft flew through turbulence and icing represented months of training compressed into minutes of critical performance. The difference between mission success and catastrophic failure often depended on the skill and dedication of individual technicians operating sophisticated equipment under combat conditions. The resistance fighters who constructed and operated the Eureka beacon system demonstrated engineering creativity that would have challenged professional researchers working under ideal laboratory conditions. Using salvaged components and improvised power supplies, they created electronic systems that met military specifications despite lacking access to proper testing equipment, technical documentation, or replacement parts. Their achievement reflected broader patterns of innovation and adaptation that characterized resistance movements throughout occupied Europe. Faced with overwhelming German military superiority, civilian populations developed technological and tactical solutions that leveraged limited resources against systematic oppression. The electronic beacon that guided Allied supply aircraft represented countless hours of dangerous work by individuals whose names never appeared in official military record. The strategic implications of Operation Christmas Box extended far beyond immediate tactical success to fundamental questions about the nature of modern warfare. The integration of advanced technology with traditional resistance techniques established precedents that would influence military operations throughout the Cold War and into the 21st century. The emphasis on precision, coordination, and technological advantage over numerical superiority became defining characteristics of successful special operations. German military analysts studying captured equipment and interrogation reports in the months following the operation recognized that they faced adversaries who had achieved fundamental breakthroughs in the relationship between technology and tactics. The ability to conduct precision operations under extreme conditions represented capabilities that German forces could not match despite their own significant technological achievements. The industrial capacity required to support widespread deployment of advanced navigation equipment reflected broader American advantages that became increasingly apparent during the final year of the European War. Manufacturing facilities capable of producing electronic components to military specifications, educational institutions that trained skilled technicians, and research laboratories that developed innovative solutions all contributed to operational capabilities that German planners had not anticipated. Post-war interviews with German commanders revealed consistent underestimation of American technological and industrial capabilities throughout the conflict. Trained in military traditions that emphasized individual heroism and tactical brilliance, they struggled to comprehend adversaries who treated warfare as an engineering problem requiring systematic solutions based on quantitative analysis and technological superiority. The mathematical precision achieved during Operation Christmas Box reflected cultural attitudes toward technology and innovation that distinguished American military operations throughout the war. While German forces achieved remarkable tactical successes through superior training and equipment quality, American forces consistently demonstrated advantages in logistics, coordination, and technological integration that proved decisive over extended campaigns. The Christmas Eve timing of the operation carried symbolic significance that extended beyond immediate tactical considerations. The juxtaposition of humanitarian supply delivery with military operations reflected broader American values that influenced strategic planning throughout the war. Delivering medical supplies and communication equipment to resistance fighters during Christianity's most sacred holiday demonstrated commitment to principle that transcended narrow military objectives. French resistance fighters who participated in container recovery operations later described the psychological impact of receiving Allied support during a period when German repression had reached unprecedented intensity. The knowledge that American aircrew risked their lives to deliver vital supplies provided moral support that sustained resistance activities despite constant danger of betrayal, capture, and execution. The technological legacy of Operation Christmas Box influenced military communications and navigation development for decades following the end of World War II. The Eureka system established principles of electronic navigation that evolved into increasingly sophisticated systems used throughout the Cold War and beyond. GPS satellite navigation, precision-guided munitions, and modern special operations tactics all trace their conceptual origins to wartime innovations pioneered during operations like Christmas Box. The declassified files of Operation Christmas Box, released to researchers decades after the war ended, reveal the extraordinary complexity of seemingly routine supply operations. Coordination between intelligence services, air transport units, resistance networks, and industrial facilities required communication systems and organizational capabilities that represented major achievements in military logistics and planning. Lieutenant Donovan's post-war career in aerospace engineering reflected broader patterns of technological development that transformed American military capabilities throughout the Cold War. Veterans who gained experience with advanced navigation and communication systems during World War II became leaders in industries that developed increasingly sophisticated military technologies. Their wartime experience with the practical applications of electronic systems under extreme conditions proved invaluable during decades of technological competition with Soviet forces. The human stories underlying Operation Christmas Box remained largely unknown for generations after the war ended. Resistance fighters who risked execution to operate beacon equipment, aircrew who flew through mountain valleys in ice storms, and support personnel who planned and coordinated complex operations all contributed to tactical success that influenced strategic outcomes across entire theaters of warfare. But perhaps the most significant lesson of Operation Christmas Box lay not in its immediate tactical success, but in its demonstration of principle that would guide military operations throughout the modern era. The integration of advanced technology with human courage and skill, the coordination of diverse organizations toward common objectives, and the application of industrial capabilities to tactical problems all became defining characteristics of successful military operations in the decades that followed. On Christmas morning, 1944, as French resistance fighters distributed supplies delivered by American aircrew using British technology, the future of warfare became visible in the precision of electromagnetic signals cutting through alpine darkness. The age of technology-driven military operations had begun, and the world would never be the same. The silence that followed Operation Christmas Box carried its own significance. German intelligence service, monitoring Allied communications throughout the region, detected no unusual radio traffic, no celebration of tactical success, no communication errors that might reveal operational detail. The professional discipline demonstrated by all participants reflected training and organizational culture that German commanders grudgingly admired, even as they struggled to counter its effect. Decades later, military historians would identify Operation Christmas Box as a pivotal moment when traditional warfare gave way to technological sophistication that would define military operations throughout the remainder of the 20th century. The precision achieved during that Christmas Eve operation established standards that influenced special operations doctrine, navigation technology development, and the integration of intelligence services with military logistics for generations of military professionals who never knew the names of the men who made it possible. The story of Operation Christmas Box reminds us that history's most significant moments often occur in darkness, witnessed only by those who risk everything to ensure that freedom's light continues to shine. These men understood that courage without precision is merely heroism, but precision guided by courage becomes victory. Their legacy lies not in monuments or medals, but in the continued existence of the principles they fought to preserve. What would you risk to ensure that such courage and precision are never forgotten? Their sacrifice demands that we remember, that we share their story, and that we honor their dedication to ideals greater than themselves. Please subscribe to this channel and share this video in respect for those who gave everything to ensure their story could be told.